Imagine holding your thumb up to the night sky. That tiny patch of darkness your thumbnail covers? To the naked eye, there's nothing there, just void, just black. But point the James Webb Space Telescope at that same patch, and suddenly, thousands of galaxies appear. Galaxies older than anything we've ever seen. Galaxies that shouldn't exist yet. Galaxies that, according to everything we thought we knew about the universe, arrived billions of years too early to the party. And scattered throughout every single one of Webb's deep field images, hiding in plain sight, are something even stranger. Tiny crimson pinpricks of light. Impossibly bright, impossibly small, impossibly old. Astronomers call them the little red dots. And from the moment they were first spotted in the summer of 2022, they have refused to behave. Some scientists think they could rewrite the story of how black holes are born. Others believe they represent an entirely new class of cosmic object that we have never encountered before. And a handful of researchers have gone even further, suggesting these tiny red smudges could be telling us that our entire model of the universe is wrong. I'm Nick, and you're watching Astro X. Join me today as we explore what the little red dots actually are, why they appeared in almost every image Webb has ever taken, and what a single object, nicknamed the Cliff, has forced scientists to go back to the drawing board entirely and consider that something genuinely new may be lurking at the dawn of creation. To understand why these tiny red objects matter so much, you need to understand what astronomers expected to find when Webb turned on its cameras. The James Webb Space Telescope launched on Christmas Day 2021, the result of over 2 decades of engineering and a cost of around $10 billion. It is the most powerful space telescope ever built. Its primary mirror spans 6.5 meters, roughly the width of a city bus, made from 18 individual gold-plated hexagonal segments aligned with such precision that they effectively function as one enormous eye. And crucially, Webb sees in infrared light, which lets it peer through the dust clouds that blocked Hubble's view and detect light that has been stretched by the expansion of the universe across billions of years of travel. Astronomers had waited a long time for this. The plan was to use Webb to find the universe's very first galaxies, the ones that formed in the chaotic, violent centuries after the Big Bang, around 13.8 billion years ago. Current models predicted these early galaxies would be small, faint, and relatively few in number. Delicate infant structures still figuring themselves out. What Webb found instead was chaos. Not only were there far more ancient galaxies than expected, but some of them were enormous, disturbingly enormous. Dozens of these early galaxies appeared to weigh as much as 100 times more than any theoretical model had predicted they should. Scientists quickly nicknamed them the universe breakers, because if real, they could not exist within the framework of our current understanding of cosmic evolution. You simply cannot grow a galaxy that massive in the time available without breaking the physics. But nestled within this already chaotic picture was something even harder to classify. Something that first appeared as a curiosity, then as an anomaly, and then, the more Webb looked, as an epidemic. The little red dots. In the summer of 2022, less than a month after Webb delivered its first scientific images, astronomers noticed something unexpected. In picture after picture, at almost every distance Webb looked, there were these tiny, compact, intensely red objects. They were showing up with remarkable consistency. There were hundreds of them. MIT astrophysicist Rohan Naidu put it plainly: they are in every single image the telescope takes. Subunit 1, First Contact. What are we actually looking at? Here's the thing about the little red dots. When you first see them in a Webb image, they look like almost nothing. A few pixels, a faint smear of red. The average person would scroll right past them. But the trained eye sees something extraordinary. These objects are not just red because they're old, though that's part of it. When light travels across billions of years of expanding universe, its wavelength stretches, a process called red shift, shifting visible light into the infrared. That's why distant objects look red in Webb's cameras. But astronomers quickly realized that the little red dots weren't just red shifted, they were also intrinsically red. Something about the objects themselves was causing additional redness, most likely enormous amounts of dust blocking other wavelengths, or a population of very old, cool stars. The first major scientific paper on them, published in March 2024 and led by astrophysicist Jorid Mathy of the Institute of Science and Technology, Austria, described them as appearing heavily enshrouded in dust. Mathy's team also gave them their now famous nickname. And here's where it gets strange. Despite being smaller than typical galaxies, often just a fraction of the size, these objects appear unusually bright. Something is generating an enormous amount of energy inside a very small space. The two most obvious candidates are a galaxy packed with an intense burst of star formation or a supermassive black hole at its center, consuming surrounding gas and radiating ferocious amounts of energy. The problem? They don't quite behave like either. Subunit 2. The black hole theory and why it doesn't fully fit. Early on, many astronomers coalesced around the black hole explanation. Active galactic nuclei, or AGN, are galaxies powered by supermassive black holes voraciously consuming matter. As material spirals into the black hole, it heats up to millions of degrees, emitting tremendous amounts of light and radiation. This was a natural fit. It explained the brightness, it explained the compactness, and measurements of how fast gas was spinning inside these objects, thousands of kilometers per second, was consistent with the gravity of a black hole. But something kept not adding up. Active galactic nuclei are typically X-ray loud. Black holes feasting on surrounding gas should blaze in X-ray wavelengths. The little red dots produce almost no X-ray emission at all. Scientists tested this repeatedly and came up empty. The silence was deafening. Then there was the mass problem. If these were black holes, they were far too massive, far too grown up for a universe that was only 600 million years old. Some of the implied black holes were hundreds of millions of times the mass of our own sun. That is not supposed to be possible. You can't grow a black hole that large that fast, not under the rules as we know them. Here's a number to let sink in. The universe was less than 5% of its current age when these objects existed, yet some appeared to harbor black holes approaching the mass of the ones we find today in billion-year-old galaxies. It's the equivalent of finding a fully grown adult human in a hospital's newborn ward. Something is off. Astronomers agreed on one thing. To solve this mystery, they needed spectra. Not just images, but detailed breakdowns of how much light these objects emit at every individual wavelength. That fingerprint of light tells you the temperature, composition, velocity, and mass of whatever is producing it. And securing spectra for objects this ancient and this faint, even with Webb, is extremely difficult. Telescope time is competitive, the waiting list is long. But once the significance of the little red dots became clear, numerous groups around the world began competing for observation time. One of those successful proposals came from a researcher named Anna de Graaf at the Max Planck Institute for Astronomy in Heidelberg. Subunit 3, the Rubies Program, a year of listening. De Graaf and her team called their program Rubies, the Red Unknowns, Bright Infrared Extragalactic Survey. Between January and December 2024, they used nearly 60 hours of Webb telescope time to collect spectral data from 4,500 distant galaxies. It became one of the largest spectroscopic datasets ever obtained with JWST. What they found was a mixed picture. Some of the little red dots did show signs of actively feeding black holes. Many had what are called broad Balmer emission lines, a signature of hydrogen gas moving at tremendous speed, consistent with material being dragged into a gravitational vortex. Around 80% of the objects with good spectral data showed this signal to some degree. But the gas surrounding these black holes was cold, not hot. Not the millions of degrees plasma you expect around a feeding supermassive black hole. Instead, the spectra showed something that looked almost like the cool atmosphere of a low-mass star. It's an elegant answer, really, one researcher put it, because we thought it was a tiny galaxy full of many separate cold stars, but it's actually, effectively, one gigantic, very cold star. This is the moment things got genuinely strange. Subunit 4, the cliff, when one object rewrites the rules. In July 2024, the Rubies team noticed one particular little red dot that was off the charts, literally. They nicknamed it the cliff. Its light had taken 11.9 billion years to reach us, meaning it existed when the universe was less than 2 billion years old. Even among little red dots, it was extreme. Unusually bright, unusually massive, unusually strange. And its spectrum contained a feature that nobody had seen before in an object like this. A dramatic, nearly vertical drop in brightness, a spectral cliff at a specific wavelength. This feature is called a Balmer break, and it normally tells you about the light absorption properties of hydrogen gas in a stellar atmosphere. The kind of cool, dense hydrogen you'd find wrapping around a relatively cold star, not a black hole. Anna de Graaf later described the impact. The extreme properties of the cliff forced us to go back to the drawing board and come up with entirely new models. What was happening inside the cliff? As best as the team could determine, it was not a galaxy in any traditional sense. It appeared to be a single object, a supermassive black hole consuming matter so rapidly, pulling in so much surrounding gas that it had effectively cocooned itself in a dense sphere of hydrogen. And that hydrogen shell was cold enough and thick enough to produce the atmospheric signature usually associated with a red giant star. The researchers proposed a new class of cosmic object to explain it, a black hole star. Not a star, not a galaxy, not a quasar, but something in between. A supermassive black hole wrapped in such a thick fog of infalling gas that it looks, from the outside, like a single enormous cold stellar atmosphere. So, what are the little red dots? As of 2026, scientists do not agree. There are at least 3 serious competing theories, and each one carries different implications for our understanding of the universe. The first theory says they are active galactic nuclei, growing supermassive black holes in the process of building themselves, wrapped in dust and gas that suppress their X-ray emission. Under this model, the little red dots would be a normal, if extreme, stage of black hole evolution that we simply hadn't seen before because no telescope before Webb had the sensitivity to find them. The second theory, motivated by the cliff and the Rubies findings, proposes they are black hole stars, an entirely new class of object that has never been confirmed to exist. A supermassive black hole so voraciously consuming surrounding gas that it forms a quasi-stellar atmosphere, cold on the outside, catastrophically violent within. If this is real, it would mean we have discovered a new fundamental type of celestial body, and it could explain how black holes managed to grow so enormous so quickly in the young universe. Penn State cosmologist Joel Leja described the implications. No one's ever really known why or where these gigantic black holes at the center of galaxies come from. These black hole stars might be the first phase of formation for the black holes that we see in galaxies today. And then there is a third theory, one proposed in the summer of 2025 by a separate team. What if the little red dots are not black holes at all? What if they are stars? Specifically, a theorized class of object called population 3 stars, the hypothetical first stars that ever formed in the universe, made almost entirely of hydrogen and helium before any heavier elements existed. These stars, if they ever existed, would have been unimaginably massive, perhaps 1,000,000 times the mass of our Sun. They would have burned through their fuel in a few thousand years, a cosmic eye blink, and they have never been directly observed. Until, this team suggests, perhaps now. The theoretical models of these primordial giants apparently match the spectral features of the little red dots with unsettling accuracy, including that steep Balmer break, that cliff. Under this hypothesis, what Webb is seeing is not a black hole wearing a stellar disguise. It is the last few thousand years of the most massive stars that have ever existed, the dying ancestors of every black hole in the universe. That's just my reading of it, and it remains deeply contested, but I find it the most beautiful possibility. Here's the honest answer. We don't know. And the strangest thing about the little red dots is not any single feature. It is the combination of features that no existing model cleanly explains. They show no X-rays when they should. They appear too massive, too early. Their gas is too cold. They vanish from the cosmic record after about 1.5 billion years post-Big Bang, and we don't know why they stop appearing. Something created these objects in enormous numbers in the first moments of cosmic history, and then they were gone. There's something quietly humbling about all of this. We built the most powerful space telescope in human history. We launched it 1,000,000 miles from Earth, unfolded it in the cold of space, and pointed it at the darkest corners of the sky we could find. And what we found there, in the very first images, were objects we had no name for. Not unexpected variations on known things, not slight surprises. New things. Things that force us to hold our models up to the light and ask whether we'd been reading them correctly. The little red dots existed before our own Milky Way had fully formed. Their light has been crossing the universe for over 11 billion years just to be caught in a mirror made of gold and beryllium, orbiting the Sun. Whether they turn out to be black hole stars, primordial giants, or something we haven't named yet, they are a message from the beginning of time, and we are still learning to read it. Webb is still watching, the data is still coming in, and somewhere in that stream of infrared light, the answer is almost certainly already there, waiting for the right eye to find it. If you found this as mind-bending as I did putting it together, I'd genuinely love to know what you think. Drop your theory on the little red dots in the comments. Are they black hole stars? Dying primordial giants? Something else entirely? If you want to support more deep dives like this one, you can find the link to your membership or Patreon in the pinned comment below. Members get early access to videos, ad-free viewing, and the chance to submit questions that shape future episodes. And if you're hungry for more, the link to the playlist is right here. I'll see you in the next one.